Have you ever wondered why it takes so long to boil water? Do you know that it takes longer to boil some liquids than it does others? For example, if you were to heat the same amount of water and alcohol, the alcohol boils first. Well, what accounts for this difference? The answer is specific heat capacity. Specific heat capacity, or simply specific heat, is the amount of heat required to change the temperature of a substance. As water requires more time to boil than does alcohol, you might conclude that water requires more heat than alcohol to raise its temperature. In other words, water has a higher specific heat capacity. That conclusion would be accurate. To better understand specific heat capacity, we need to distinguish between heat and temperature, as both of these terms are used in its definition. Let's look at an example to help us understand the difference between heat and temperature. Consider two beakers of boiling water, with 1 liter in one and 2 liters in the other. If both are boiling, they have the same temperature. You see, temperature is defined as the average amount of kinetic energy in the substance, where kinetic energy is the energy of motion. The molecules in each pot have the same average energy of motion, or average amount of kinetic energy. In other words, the water molecules in each pot are moving at the same speed. Temperature is measured in degrees Celsius, degrees Fahrenheit, or even Kelvin. However, 2 liters of boiling water contain more heat than 1 liter of boiling water, even though they have the same temperature. In the context of specific heat capacity, heat is the total amount of energy in a substance, and heat is sometimes referred to as heat energy, in which energy is the ability to do work. In the scientific community, energy is measured in joules, but also can be expressed as calories. So while heat and temperature are different measures, they are certainly related. Temperature increases as heat is added to a substance. Likewise, temperature decreases as heat is removed. Let's do a little experiment. All we need is a beaker of water, a thermometer, and a power supply that generates heat. The power supply will measure the amount of heat that we add to the water. Let's say that we heat 10 milliliters, that is 10 grams of water, 10 degrees Celsius. In doing so, the power supply registers 420 joules. That means it took 420 joules of heat energy to raise 10 grams of water 10 degrees Celsius. We can use this information to calculate the specific heat capacity of water. All we need is to figure how much heat is required to raise the temperature of 1 gram of water 1 degree Celsius. The equation for specific heat is as follows. Specific heat capacity equals heat energy divided by the product of the mass of the substance multiplied by the change in temperature. The equation is read specific heat capacity equals heat energy per gram per degree Celsius. Now, if we plug in our results, we get the following. Specific heat capacity equals 420 joules divided by 10 grams multiplied by 10 degrees Celsius, which is calculated out to be 4.2 joules per gram per degree Celsius. What does that mean? That means it takes 4.2 joules of heat energy to raise 1 gram of water 1 degree Celsius. To make it even easier to remember, let's convert joules to calories. Remember, both are units for energy. There are 4.2 joules in 1 calorie. Therefore, we can say the specific heat capacity of water is 1 calorie per gram per degree Celsius. That's pretty easy to remember. If we do the same experiment with alcohol, it would take 255 joules to raise 10 grams 10 degrees Celsius. Thus, the specific heat of alcohol is 2.55 joules per gram per degree Celsius. How neat is that? That's pretty neat. As I mentioned in the opening paragraph, not all substances have the same specific heat. The specific heat for water is actually quite high. The specific heat for alcohol is about half that of water. Yeah, we calculated that in the example above. The specific heat of air is less than that of alcohol. Rocks and metals are even lower yet. Well, how does all this information help us? Simply put, life on this planet would not be possible if not for water's high specific heat. Materials with high specific heat, such as water, can absorb and release a lot of heat without much of a temperature change. Let's consider the ocean. The ocean absorbs heat during the day and releases heat at night, and that helps us to maintain a relatively constant atmospheric temperature. That's why coastal regions have moderate climates compared with more inland regions. At a more personal level, our bodies contain a lot of water. In fact, they're mostly water. And our body water helps to maintain a relatively constant internal temperature, and we need that in order to maintain life. In review, specific heat capacity is the amount of energy needed to change the temperature of a substance. Now, in this context, heat is sometimes referred to as heat energy, and it's the total energy contained within a substance. Energy is simply the ability to do work. Heat energy, along with other forms of energy, is measured in joules or calories. Temperature is the average kinetic energy of a substance, and it's expressed as degrees Celsius, degrees Fahrenheit, or Kelvin. The temperature of a substance changes as heat is added or removed from the substance. Specific heat capacity is measured by determining how much heat energy is needed to raise 1 gram of a substance 1 degree Celsius. The specific heat capacity of water is 4.2 joules per gram per degree Celsius, or 1 calorie per gram per degree Celsius. This high specific heat of water allows water to absorb and release a lot of heat and maintain a fairly constant temperature.